Let's get started. Thanks for joining. My name is Petre Popescu, and I'm here to talk about Phoenix. It's a template engine for Spring and Spring Boot, which I developed, and it's still in development. Before talking about the Phoenix, a few words about myself. I have more than 10 years of experience in software development. I work mostly on the back end, but like to dip my toes in other areas: front end, SDK development, gaming. I currently work for Speechify on Kotlin multi-platform, and I'm developing their SDK. I work mostly in Java, but again, because nowadays you have to be, you need to know everything. I started to work on front end a bit with JavaScript. For those who remember, I also worked in the past with ActionScript 3, for example. That's the era of Flash. I'm a gamer. As a fun fact, my Steam library has more than 1,000 games. And like most of you here, I'm a huge geek with the good and the bad. So how do we build web applications? I know it's a very complex question, so let me rephrase it. How do we build the front end and the UI part of a web application? When web apps started to emerge, the initial approach was to use server-side rendering. This meant that the client, in most cases a web browser, was sending a request to a web server. That web server computed the HTML content. It retrieved all the data from the database or from other resources that are needed, computed the HTML part, and was sending it back to the client. This was server-side rendering. It was pretty good, fast, and it did the job. But web applications continued to evolve, and developers started to build applications that are more complex. They wanted the front end to evolve as the user interacts with the page. They needed elements to be added, elements needed to be removed or changed, and so on. And this led to the development of JavaScript frameworks, React, Angular, Vue. I know you've heard about many of them. And this approach, called client-side rendering, was that using JavaScript, the developer created different components that they mashed together, but it didn't have the data. It had the information needed just to render how the web page should look. And for the data, it again needed information from the backend. So it was sending a request to the backend, and it was retrieving, usually as a JSON string, the needed data. And everything got assembled together using JavaScript, and voila, you have a web page. Single page applications, for example, use this approach. And it was very well. It allowed the development of complex web applications that evolved as the user continued to interact with the application. But it also had some problems. It took the control, some of the control from the backend and gave it to the client, because now the user and the client application that was running on the user's machine was the one requesting the data. And I know you saw many web apps that did, 10, 20 requests just to render one simple web page. And in many cases, they were requesting more information than was actually needed to render that web page, because developers on the backend were creating one endpoint that returned the entire structure of an object, even though, for example, it only needed 3 fields. So the third approach was still client-side rendering, but a bit more smart. And what it did is GraphQL was that using GraphQL, the client application was sending a GraphQL query, and it's told the backend, okay, I only need this information, not all the entire object. I only need these 3 fields, or I need the object in this particular way. And the backend then computed the query and returned the data back to the client, and again, it added the elements. Everything worked, but now the web application, the client side, became more complex because it needed to send the query, and the backend needed to be able to answer based on that query. So things were moving in the right direction, but there were still many obstacles that needed to be solved. I don't want to debate which approach is better. There are pros and cons for all three of them. And if you developed web apps in the past, I'm sure you have your own opinions on which to use. There can be an entire talk just which one is better and the pros and cons. And most big applications use a hybrid approach where there are elements that are created using server-side rendering and elements that are done using client-side rendering. But I do want to talk about the disadvantages of current template engines that use server-side rendering, especially those available for Spring. Here, I'm sure you've heard about JSP, Thymeleaf, Freemarker. These are among the most well-known template engines available for Spring at the moment. And most of them suffer from the same problems. They are very slow because with the exception of JSP, the template isn't compiled, but it's interpreted. So because of this, you don't benefit from the advantages that the Java compiler has, and you don't have the template well optimized. So they are slow, they are complicated, and have their own syntax. For example, Thymeleaf have its own utility classes for traversing a list. There are multiple syntax expressions, dollar, pound, tilde, and so on, and you have to know when to use and which one. And why JavaScript frameworks started to become popular, it's hard to create dynamic web pages. But they did make some decisions that are well made, and let's try to learn. Let's not reinvent the wheel every time we develop a new technology. Let's see what previous technologies did well and what can be improved. And that is the approach I started when I started to develop Phoenix. It was inspired by Twirl and Rocker. For those who don't know, Twirl is the template engine used by Play framework. I don't know, anybody here used Play? No? Great. Play isn't that popular, but it did have some great ideas. And Rocker is another lesser-known template engine for Spring. So I got inspiration from other template engines. As I said, let's not reinvent the wheel. See what previous technologies did well and build upon those. I wanted something that is easy to integrate in Spring, and I wanted something very fast. Template engines, especially Thymeleaf, are slow. I wanted mine to be fast and easy to learn. No utility classes, no hidden syntax. Any Java developer can go straight away and start developing front ends using Phoenix. And as a contribution, I wanted it to be open source. So let's look over some key features that Phoenix has. So using a razor-like syntax, just the @ character, you can integrate Java and HTML directly in your template. You can have if statements, else, for statements. I plan to have switch soon enough. And using just the @ character, you can easily differentiate between what is HTML and what is JavaScript. And this allows you to develop web pages easily and without needing to learn a new syntax. You already know Java, most of you already know HTML, combine them. And every template gets parsed and compiled into a Java class. This way, the template gets rendered very fast and no need for other boilerplates or other utilities. Everything is a Java class that you can use. But now that you have your template fine, compiled, and everything, you need to be able to return the HTML page back to the client. So inside the controller, I added the Phoenix result. So the controller can return any Phoenix result at the moment. And what is a result? Well, a result is the computation of the Phoenix template. And you can pass any object as long as it's serializable. If you pass a normal object, it will be translated to a JSON, and it will return a JSON string back to the client. This way, Phoenix can be used easily in web apps that also need RESTful endpoints. However, there is also a Phoenix view, and a Phoenix view is the template that returns the HTML part. And if you return a Phoenix view, which is defined by the name followed by input parameters, the client will receive the HTML page which it can render. So the browser already knows how to render HTML pages. And the view is easily defined. You have a name, and if it's part of a subdirectory, you append the directory as well. For example, you have, in the second example, the to template is in the user directory. And you have utility classes for returning status code 200, okay, 404, not found, any HTTP status code you want, and even redirects are supported. And this way, from your controller, you just return a view with ease, and the template gets rendered with all the input parameters you sent. And inspired by other template engines, and this is a feature that is a must, is to have things modular. You don't want to create the same component multiple times. If you have a web page that has, for example, a button, you can create it as a fragment. The terminology comes from Thymeleaf, but you call it modules, call it components, segments, however you like. And you can create that fragment and then import it in a bigger template. And this way, templates are built incrementally. You have different components that you can combine and can reuse. And using an inspiration from Kotlin this time, you can have additional content passed directly to the template. In the example here on the right side of the screen, you will see that I pass to that template both an input variable, that A, and additionally, I pass an HTML content. More on this content block later. And I also have one special feature called client-side fragment retrieval. And with this, I'd like to go into the parts that are unique or not available on other template engines except Phoenix. So I mentioned client-side fragment retrieval. What is this? By default, it is off. However, once enabled via configuration, a new endpoint gets activated in your Spring application. And using this endpoint, you can call a fragment, pass the needed parameters. At the moment, only primitives are supported, like int, string, double, and so on. And the Spring application, the backend, computes the HTML just like it would do for a normal web page and returns the HTML content. Now, using simple DOM manipulation with JavaScript, you can insert that component wherever you need it in the page. This way, you don't need to develop the same component twice, once in your template engine, once using JavaScript. You have it already developed in Phoenix, and you can retrieve it. Another feature that is not available for other template engine is type-safe routing. When the templates are compiled, instead of having the URL enter directly, you can compute it at runtime. And this way, you are sure that the URL is a valid one, because Phoenix supports both get mapping, post mapping, and put mapping at the moment, and it can interpret path variables and request parameters. And this way, when you compute the URL, you pass directly the path variables and the request attributes to the method that computes the URL, and you get in return an actual URL that is valid. Another advantage that this offers is that if your URL changes, you only need to modify in your controller. No need to do any additional changes in the template because URLs are computed at runtime. I mentioned earlier content blocks. So what are content blocks? Content blocks are portions of HTML that can be reused anytime you want. In this case, I define my content where I have a simple paragraph and a link. And I can reuse it and add it multiple times on the same page. This is because these content blocks gets computed into a Phoenix content object. What other advantage does this have? Well, as I mentioned earlier, you can send any content block directly to another template. This way, it is very easy to have templates that accept additional HTML. For example, you have a header template that in some pages will require additional HTML or additional imports. And instead of using a simple content block defined as a variable, you can pass it directly under curly braces to the template. And if the last object from the Phoenix, from the arguments from the template is a Phoenix content, everything will work and no need to instantiate explicitly another variable. Now, templates are very fun and nice, and they make everything work. But complex web applications require components that usually have the HTML part, maybe some CSS to style everything, or maybe even JavaScript. By default, everything in Phoenix is in the HTML section. However, you can explicitly declare other sections. CSS and JavaScript are the prime suspects here, but you can use any name you want. There are no restrictions, and you can have as many sections as needed. Why is this helpful? Well, combined with insert at and insert once tags, now you can easily specify in your fragment where the needed code needs to be added. This way, if you add another fragment, the content of that fragment is added to the right section, and the HTML page has a cleaner and more robust source code generated, and you can specify easily if certain parts of that fragment need to be added only once. For example, here I have a button that also has a CSS class and a JavaScript that just logs that the button was added. And even if I add the same button 2 times, 3 times, or more, I want the CSS to be added only once because it's the same style for all the buttons. And using @insert once, I can do this. So here's a short example. I have my main template, and I call my button twice. And as previously, I have the link with a JavaScript and the CSS part. And once the template gets compiled and gets executed, I have back a HTML page where the CSS for the button was added once, even though I have the button twice, and the JavaScript was added 2 times because that was how it was defined, and both of them were in the right sections. This way, the web page is more robust. As I mentioned, I wanted Phoenix to be fast. So since Thymeleaf is one of the most widely used template engine for Spring, I started to run some benchmarks. I created a web page in Thymeleaf, in Phoenix, and ran the page 100,000 times. And when I first saw the results, I thought, okay, something's off. I definitely made something bad and that benchmark doesn't work. Because as you can see, Phoenix is orders of magnitude faster. For the exact same web page, you can barely see Phoenix on the graph. So I started to develop the same benchmark, the same web page in Rocker, because Rocker is one of the fastest, if not the fastest, currently available template engine for Spring. And yeah, the benchmark was okay, was right. Phoenix is indeed faster than Thymeleaf and even slightly faster than Rocker, even though it offers more features and it is it will be better on the long run because of the features and the generated templates. So yeah, I think, you know, and say, yeah, nice presentation, but is this actually useful and is it actually available? Well, yeah, and you can start using it. And I made a simple demo application. I have here a login page that I built using Phoenix. I will show the source code soon enough. And Bootstrap for the UI framework. So I have a login page. Let's enter a bad password. Yeah, hope the demo works. Yeah, I have a breaking point. Yeah, so I have invalid username or password. Let's look a bit over the source code. Making things bigger so you can see. So I define an error message as an argument. I call a head template. I provide a title and any additional includes that I need. Nothing for the login page. It's pretty simple, pretty straightforward. I have all the code here and let's search for where I display the error message. So, as I mentioned, you can just insert Java code. I have an if, and if the error message is present, I can just display it. Otherwise, moving next, we have the form, and Phoenix offers an utility for inserting the cross-site request forgery token. This way, you can integrate with Spring Security, and you have the CSRF token added directly to the form using as a hidden input. You can also add it as a meta tag if needed, but that's another story. So let's actually log into the app. Yeah, it's a simple code sharing application. I have a slider here to make things bigger or smaller, and I have different folders and different code snippets. I also have a breadcrumb here at the top. Everything works. But let's look a bit over the code because now the web page is far more complex. I have animations for hovering effect. I have this breadcrumb. Let's look how this web page was created. Again, I have an argument, and this time I receive as input an entire data transfer object, a DTO. For Phoenix templates, you can have any Java object as input. I have a CSS section here. And moving down, I have this breadcrumb. And for the breadcrumb, I call a method to breadcrumb list. What does this do? This utility class, is it visible? Let's make it bigger. So this method was imported as a static import directly from our source code. If I open it, you'll see that this comes from an actual Java class, because Phoenix accepts any import. It can be a static import if needed, for example this breadcrumb list, or any class from your source code. And with it, I traverse the list, have each element, create another variable, and return the actual URL. Again, I'm using type-safe routing, because now, instead of pasting and having the actual URL written, I can call Phoenix, and it will calculate the route accordingly. And because this endpoint accepts input variables, if we look in the code, you will see that I have a folder with the ID of the folder. It is passed directly as an input to the controller and the render method. This is the actual controller class that renders the page and the actual method that is being called. What else? Moving a bit down here, I have my actual browser for the code, where I have different folders and different code snippets. And for each code snippet, for each child of that folder that I'm currently viewing, I call another template. And let's look over this template. This is the code or folder template. As you can see, it's the same name. And it's under the code browser, code or folder. This is the folder, and this is the actual template that is being called. And here, let's make it bigger. Again, I receive arguments. Any Java object can be as an argument. I can import an enum and compare it. And depending on what type of object, it's either a folder or snippet, or I have code groups as well. I render the appropriate icon along with a name and everything. And there is also a CSS part. This means that every time a folder or a code snippet icon is added, I also need to add the CSS, but because it is with insert once, the CSS part is added only once for the first time the folder gets called. So if we go back to our web app, look at the code. In the head, where I have the CSS section, you'll see that the CSS for the button was added only once, even though I have both a folder and a snippet. This is thanks to the insert once tag from Phoenix, which knows exactly to insert the CSS part in the bigger template, in the color template, where it is needed, precisely here. And I can create a new code snippet. Let's inspect the page again. So I have this form. Where is it? Form. Here it is. So I have the form, and you see that I have the action set as the URL. If I look in the new snippet, I added here the URL directly as the URL, as a string. But as I mentioned, you can use type-safe routing or reverse routing to calculate the URL directly. And yes, comments are supported in Phoenix. Now, instead of having the URL, I just have a call to the router, which calculates the URL for that form. And if I recompile the application and relaunch it, you'll see that now the URL has changed slightly, and this is because at this moment, the URL is calculated by Phoenix and not the static string that I inserted. And let's add my test snippet. I can add tags. This is just a demo application. Select the programming language. Here should be a button. Yeah. And I added my snippet directly to the folder. Everything works. This shows that Phoenix can be used. You can start creating web applications directly in it, and it should work just fine. Not here, here. But Phoenix still has some work that needs to be done. It started mostly as a proof of concept, and it slowly got a bit out of hand. I think you also had similar projects in the past that, oh, let's see if I can do that, and then, oh, look, I have something that actually works. But there are still things that need to be done. There are features that need to be added. At the moment, I don't have a build pipeline. So if you want to use Phoenix, get the code because it's open source, compile it, and import the jar. You don't have syntax highlighting properly and autocomplete in IntelliJ. This is something that I want to add, better IDE integration. And I'm working on making Phoenix 100% compatible with Rocker. At the moment, Phoenix is about 90% compatible, but I'm working on making it fully compatible so that if somebody already has an application developed using Rocker, you can just replace it with Phoenix and it will work. And you will also have new features and slightly faster. I know that maybe 80 milliseconds for rendering web page doesn't seem much, but as you saw in the benchmark, it can quickly add up, and once you have thousands of requests, it can slow your application down. And also I need to do some rework and some refactoring. Again, it started as a proof of concept, so not everything is as elegant as I would like it to be. You can read more about Phoenix at its dedicated website. There you'll find code examples, you'll find how the benchmark was created, you will find the documentation for all the tags that are available. I only scratched the surface with what Phoenix can do in this presentation. There are multiple more tags that greatly enhance and make it easier and faster to develop web pages and web applications. So please take a look over there. And if you have any suggestions on how to make Phoenix even better or new feature that you'd like to have, don't hesitate to write, or why not, a pull request. Thank you for listening. We still have a few minutes left, so if there are any questions, now's the time.
Maybe just one question about the controllers.
Yeah.
You have the input layer, and you say, for example, I make the form dynamic based on the control. So where do you configure the rules?
It's
You wrote rules, and then you give the rules.
it's calculated by Phoenix based on the controller classes that are available in the application. You just define the mapping as you do in Spring, and Phoenix automatically picks them up and calculates the routes.
So you have the classes that are annotated with controller.
Correct. And from there, I get the methods that are with get mapping, post mapping, and put mapping. And from there, I get the path variables and the request attributes in the same order as they are defined. For example I showed you, where is it? The form. This is the create snippet. And if I go in the code snippet controller, you will see that create snippet is a post mapping, and it also has other input attributes, the DTO for the form and the authentication information for the current user. But here I don't have any parameters. That is because nothing is annotated with the path attribute or request parameter. However, if I go to the code browser controller, I have here the authentication again, but I have the folder as a request parameter. And if I go, where do I have the browser? So here, if I click on a folder, you'll see that the request attribute folder gets automatically populated with the ID. And so similar for the breadcrumb. Yeah, if I go to code browser, the breadcrumb is the best place to see this. I have the route, code browser controller, render my code, and I have the current folder .getID .toString. And actually, uh, this render my code has the same type object as input as the actual method in the controller. So here the controller render my code has a type string, but I can change it to UUID, for example. In that case, I don't even need to write toString. If you want, let's comment this. Just making small changes. Okay, and code or folder, no, it's the other one. So I don't even need toString. So now I can just compile. Yeah, demo didn't work. Why?
This was my next question. Do we get some feedback from the compiler that something broke? So if you change these HTML, Java HTML files, they are compiled, right? So
Yes, the HTML files are translated to the template files because they're not pure HTML. It's HTML with Java gets translated to a Java class. And if compilation fails, your application won't start, as it did at the moment. I'll have to check exactly what it didn't like.
In the template, since it's just a string, and if you do a typo in the string, then at some point the compiler will give you a compiler error because it's not valid.
Sorry?
So if you do a typo in the create snippet because it's only with one p or something, right?
Yeah, the compiler will give you an error.
Yeah. At which point the compiler is on?
Currently, the compiler runs when the application starts, but I do plan on making it so that you have everything compiled at build time, not at runtime. This is a feature that I would like to have. It's here, publisher split.
But now, for my example, if you do the typo in the p, you build the project, you don't get feedback. Only if you start the project, you will get feedback.
Yeah, when you start the project, you get feedback. Yeah, this is one of the limitations at the moment. As I said, it's still in development. Yeah.
You are using this to create a web application
I don't have an explicit example, but if we look at the code in the controller, you will see, not here, where's the controller? You will see that this Phoenix view returns an HTML format. And if we go to HTML format, you get different methods, one of them being get content. And using get content, you can retrieve the actual HTML content. Any other questions?
So maybe what's the plan of this new framework? You spent, I see on GitHub, a few months, right, making your own templating engine, but possibly this needs some community adaptation, right? So
Yeah, at the moment, I was the only one that worked on it. As I said, some elements aren't as elegant as I would like them to be. The section, insert at, and insert once are still experimental. They work, but I didn't test them properly with complex scenarios like a template that includes another template that includes another template that includes another template, and only one of them actually has that section that is requested. So there's still work needed there, and I'm sure that I still have some parsing bugs that will need to be fixed, but I do plan on continuing to develop this. I, it's more like, I don't know, my baby that I want to develop further. And yeah, help is greatly appreciated, making the benchmarks better, documentation, build pipeline. At the moment, I'm not very good at creating CI/CD pipelines, so yeah, that's why it's not there yet, but it will be, and hopefully soon enough. I'm developing it in my free time, so. I only used it on this demo application. I don't have my own SaaS or anything like that. And at the moment, I work as a Kotlin developer for Speechify on the SDK team. And there's nothing like that needed there. I don't know. Maybe if I'll start my own SaaS, I'll develop it using Phoenix because I know it. One more minute. Any other questions? Great. Thank you, and feel free to contact me, connect with me. You have my information on CERN's website, and hope to hear from you. Any feedback related to Phoenix or ideas on how I can improve it, feel free to write. Thank you.